There is spanning tree protocol. There is rapid spanning tree protocol. There is per VLAN spanning tree protocol. There's also multiple spanning tree as well. Well, find out what that's about next, right here on IT Pro TV.
You're watching IT Pro TV.
All right, that's right. We're about to jump into MST without the P officially. And so here to help us to understand this technology, multiple spanning tree protocol, even though I said it right there, Anthony Sequeira.
Yeah.
Anthony, I just mentioned this whole list of spanning tree protocol, rapid spanning tree, per VLAN spanning tree. Cisco also does a rapid per VLAN spanning tree plus. Why do we need another one?
Yeah, great question. Let's start right out of the gate with another one. Are you kidding me? We had 802.1D, D as in dog, and that is classic spanning tree protocol. Yesterday here in studio, we took a look at 802.1W. That's our WAPID spanning tree protocol per Elmer Fudd. And now we have 802.1S, and that is multiple spanning tree or MST. So Ronnie and I discussed how to start this episode, and it was clear. Why the heck do we need this? And it's actually really cool to think about an organization that would need this. Here's the deal. Let's say that we have a ton of VLANs, and that didn't make sense for a long time. You're like, we're not going to have 1,000 VLANs. We're not going to have 2,000 VLANs. That's just not realistic. Well, it's gotten a lot more realistic. When you think about virtualization, you think about cloud technologies, the number of VLANs starts to skyrocket. Back in the old days, in the 80s and 90s, VLANs were often just like geographic areas. So you're like, our first floor west wing, that's our VLAN. Our first floor east wing is our VLAN. Oh, we added a second floor. We have 2 more VLANs, and your 4 little VLANs are all happy. In a virtualization world, the number of VLANs really started to increase. Cisco was looking at things, and they're like, wow, let's solve a couple, and Cisco and others. So multiple spanning tree, of course, is not a Cisco invention, but they were quickly adopting it as other network vendors were. So the idea behind it is this. If you have a whole bunch of VLANs, load balancing on the links that are going to be down, like having different topologies with different blocked links, is advantageous for your overall load balancing in the design. And that gets really complicated when you have all of those VLANs that you're trying to figure that out with. But another big thing is if it's on a per VLAN basis, what if you even just wanted 2 or 3 topology designs? It's super complicated and silly, and there's so much overhead for each individual VLAN to have topology components.
Yeah, and I realized that once I started configuring the idea of per VLAN span tree, trying to get as detailed as I could, and knowing that is trying to understand that it was actually a different instance of spanning tree essentially running for each one of those VLANs, and that really does put more load, I guess,
Absolutely.
on everything that we have.
Yeah, there is an overhead associated with that. VLAN 10, here's your topology. VLAN 20, here's yours. VLAN 30, VLAN 40. And it's like, we don't need all of those. If we want 2 major designs or 3 major designs, then we would only really want there to be 3 spanning tree topologies, 3 like classes of PDU, if you want to look at it that way, associated with each of those. So it's a really interesting solution. It solves a couple of different problems. Like I said, it makes it easier for us to design a nice load balanced spanning tree topology, and it cuts down on that overhead.
Yeah, and I think that maybe for a CCNA student, so that's how I'm going to approach this, they may be like, why does it make a difference? But if you think about it, or at least when I started thinking about it, realizing like when we learned about spanning tree itself and blocking and everything, and you tried to draw out the diagram, like, okay, so draw this one out for VLAN 10.
Yep.
And then do this one for VLAN 20, but here, your bridge is going to be over here. I said,
Yep.
now do a fourth one, and all of a sudden they're like, wait a minute, it's really like this one switch over here, maybe out of the 8 ports we were using, there was really only like 2 ports that were left open. They were kind of shocked at how easily that happened. But now with multiple spanning tree, being able to reduce that down, we can add in, well, like you said, much more VLANs, and then also with less overhead, right?
You got it. It's
Okay.
really, it's not often that we see a solution addressing many different problems. And that's what this does. Now, I'm not saying everybody uses it. Okay. So keep that in mind. There's plenty of organizations out there that are like, okay, for our spanning tree, we're doing the rapid spanning tree protocol. Everything works great. Great. But for the individuals that would need these solutions, this is a powerful option. What do you say we jump in and see its configuration and verification?
All right, so we know something, at least at this point, that this is not one that just automatically is a default for any one switch right now.
That is right. Okay. You will never, and I repeat, never find this running by default.
All right, so let's take a look at the configuration itself and see if it's a lot different.
Yeah, you recognize this topology, Ronnie, because you were here yesterday.
Yes.
So this is just a quick layer 2 environment that Ronnie and I spun up. This is running all rapid spanning tree protocol. You remember in the RSTP episode, we took this topology and we converted it from the classic spanning tree protocol to the new and improved rapid spanning tree protocol. So it's all RSTP right now. The great news is, when you go in with a multiple spanning tree protocol approach, it uses, in fact, it requires rapid spanning tree protocol. So if you're in a classic spanning tree protocol environment, you could jump right to multiple spanning tree protocol and you're getting 2 for 1. You're going to immediately convert to rapid spanning tree protocol as part of that process. You can also do what we're about to demonstrate, of course. You can be at an RSTP level of your configuration, and you can drop in MSTP. Another big thing I need to tell you is, just like yesterday when Ronnie and I were taking it from an 802.1d classic spanning tree world to a rapid spanning tree protocol world, you can do this in stages, and that's how it's recommended. Go to your distribution layer switches, for example, convert them over to MST. They will interact and live just fine with devices that aren't doing that. Then you can go down to your access layer devices and convert them over. So once again, Ronnie, great news. We don't have to call everyone on the network and say, sorry, we're going to shut down the network for a couple days while we migrate over to MST.
All right, so is it a lot of configurations that we have to do?
This is an interesting configuration. I'm not going to lie to you, Roddy. This is a little weird, really, compared to what we would be used to at layer 2. It's not difficult at all, but it does require some explanation. That's why Ronnie and I are here for you. And this is also one where you are going to want to leverage the joy that is Notepad, or in my case, TextEdit on the Mac. So notice that, and we'll blow this up even more so you can see it. Notice that I have done this configuration in Notepad, and that's because, as you can see, there's quite a bit of lines of code here, and we need it to match for sure on the different devices. The number one area where you can get into trouble with this configuration is not having a congruent configuration across all the switches. So this begs for Notepad. So let's take this first group of configuration, and I'm going to get it on my clipboard, and we're going to go to switch 1, our distribution layer switch, one of them, we're pretending, and we are going to paste that configuration in, and then let me walk you through it. So the very first thing we do in global configuration mode is we issue the command spanning tree MST configuration. So right away, it's a little weird. Right. We're entering a configuration mode by saying we need to enter a configuration mode. That's pretty different for Cisco. And then notice we're in MST configuration mode, and I say name, and I give a name. I was not creative last night at midnight. What a surprise. I just called it my MSTP. Aww. So that name is going to be something that we're going to consistently have on all of our devices for the MST configuration. Now, this is interesting. Revision. So when you hear revision, you're probably thinking like the configuration revision number that we have in VTP or something like that that's going to automatically increment. That is not what this is. Think of this as the second part of the name. They're thinking like, okay, Ronnie and Anthony are going to do this my MSTP domain that they've created, and they're going to be happy with it, but then they're going to be doing network analysis and they're going to realize it's not all that optimal. So they're going to probably want to tweak it. And what we can do is Ronnie and I can go around and we can do manually, say revision 2 on our first switch and manipulate it, and then go and change all the other ones to revision 2. So it's like a version number that's associated with the name that you control so you can see where you're at in your history of MSTP topologies. So the next thing that we do is we indicate the topology instances that we want to create. So I create an instance and I give it an ID here of 1, and I say, this is so cool, right? This is so revolutionary. I say, this is the instance for this range of VLANs. From 1313 to 1500, you're all gonna be in a shared spanning tree topology. And by the way, you could use commas there, Ronnie, of course. So you could say 1313, comma, 30, comma, 20,
Okay.
if they're non-contiguous.
Right.
You can, of course, mix that. You could say, we need VLANs 10, 20, 30, 50 through 60, 71. So you've got all your syntax variations. Then you can see I have created a second instance, and I'm mapping, and that is the correct terminology that we use. We are mapping VLANs 2424 to 3000 into instance 2. So we create our domain, we create our revision name, and our revision number and our name for the MST topology. We do those 2 steps. We create our mappings to instances, and then once we're sure we've done that right, we would typically go in and set the manipulations that we want to make to the spanning tree. So notice what I'm doing here, pretty clever thing. We're going to go in and we are going to say for the instances 0 through 1, this switch 1 will be the root bridge. So I say root primary for those 2 instances. And then, this is cool, for the second instance that we're working with, we say this will be the secondary device. So it would be the failover device to be the root for those other VLANs. Now there's one thing clearly I need to explain here, and that is, where is this 0? We didn't define an instance 0. This is a best practice for you to set the root bridge of that 0 instance of multiple spanning tree. It's called the internal spanning tree instance, and its main job is so that this can interoperate with earlier versions of spanning tree. So that instance 0, that internal spanning tree, critical for interoperability, and it's often a great idea, like I've done here, to go ahead and know where the root is for that internal spanning tree.
Now that I'm starting to look at this configuration a little bit more, can I have more than 2 instances if I need to?
Absolutely, you could have more than 2 instances. Yep, great point. So now what I'm going to do is I'm ready to turn it on. I am confident that we understand the configuration inputs here. By the way, I just copied that to the clipboard. I clearly could have just typed that out. All we're going to do, in fact, I'll do it that way, is spanning tree mode, just like we did yesterday when we were looking at rapid spanning tree protocol. And we're just going to say, cut over the mode to MST. Now, verification wise, Ronnie, you are going to get so sick of hearing this from me in Encore, you'll probably give me a forearm at some point. But I love to do the primary command, right? And then I have some secondary commands that I might never use, but at least I've got them in my tool belt. So the primary command here, without a doubt, is, and it's not going to surprise you, it's show spanning tree. And, you know, I could pick one of the VLANs that is in instance 1, and you got to spell VLAN right. They're so particular about that. It's weird. So show spanning tree VLAN 1313, and look at our output. We are in multiple spanning tree mode. We said that this should be the root for instance 1.
Right.
And that's exactly what it is, Ronnie.
Okay.
And we did not do this magic on any of the other switches yet. So just like we saw with rapid spanning tree protocol when it was working with down level versions of spanning tree, this is shouting to us, you're not getting the full benefit. Yeah, we're interacting with those other switches, but they're not MST. So you better go out and do some more upgrading, because we're alone in this world right now of MST. But no problem. The great news is this still works. So now what I'll do, Ronnie, is I have the configuration here for our switch 2. And we'll get it into switch 2, and we'll just talk through a couple of points here because everything else we've covered. But watch this. I'm going to get this configuration into switch 2. Notice what we're doing here. This is the identical configuration, of course it is, where we are mapping our instances to VLANs and we're naming and giving the revision number. That has to be consistent across all your devices, or multiple spanning tree doesn't work. Now, what we do a little differently, of course, on this device is we say we're the root for the second instance, and we're the backup for the first instance. So now we've just got that load balancing in there that we wanted for spanning tree protocol, and then we turn on the feature. Now, for the other switches in our topology, it is really simple. We're not manipulating the priority values for them. We are just going in and telling them what the mappings are. So I'm going to slide over to switch 3, and I'm going to say, okay, you are now multiple spanning tree protocol enabled. Have a great day. There's your mappings. And I do that to my final access layer switch. And there we go. And now when we slide back over to switch 1 and we rerun our show spanning tree, we can see from the output that, yeah, we are good. Everybody is speaking the language of multiple spanning tree. We have this great load balancing. Right. We have efficiency because we've got a whole bunch of VLANs in instance 1. We've got a whole bunch of VLANs in instance 2. And Ronnie, we're going to wrap this up with a secondary verification command. It could be that you don't trust yourself. Maybe you didn't use the notepad approach. And you're like, geez, did I do this right from a mapping perspective? There is a, oh boy, it's been so long since I've done this command. It's show spanning tree MST and its configuration. I can't believe I just remembered that command. It's been a long time since I've done it. But look at what this shows you. This is good common sense, right? So this shows you, okay, your name is my MSTP. Your revision number that you said is 1. There is 3 devices, 3 instances configured, that's the 0 instance. That's that internal spanning tree. Notice it gets by default all the VLANs that you didn't assign to anyone else. There's instance 1, which we assigned, instance 2, which we did our mappings for, and that is just a great bird's eye view of the multiple spanning tree configuration. So that's a great command right there. By the way, one more. You can also, Ronnie, we did VLAN 1313, right? Show spanning tree VLAN 13. You could also do, I believe, no, it doesn't let you do that. Forget that point. I was confusing 2 spanning tree features right there. I always am looking at my VLANs like we did and like we're accustomed to doing. And then I do like that secondary, show me the MST configuration.
All right. Well, thank you for helping us in understanding the overall reasons why we would choose multiple spanning tree, as well as configuration. Remember, the thing that actually caught me in this was the beginning of that configuration, where we actually ended with the configuration, and then at the end, that's when we added in the mode to actually help us essentially sandwiching in the configuration between those. There is a difference between what we also saw at the distribution layer and the access layer switches as well. Now,
and Ronnie, I'm so sorry.
No, that's fine.
If we could just, I just remembered the command I wanted to show.
Sure.
One more secondary command. Boy, did I get it in just in the nick of time, right? Here it is. You go show spanning tree MST, and then you can give an instance number.
Right.
And so that's a pretty cool command notice because it is showing you. I essentially got this information by doing it the old school way, but this is kind of a new school way to say, oh, look, this is the details for the overall instance.
All right, well, you heard it here. There's a lot more to come for our Cisco Encore show, but that is enough for this episode. Signing off for IT Pro TV, I'm your host, Ronnie Wong.
And I'm Anthony Sequeira.
Stay tuned right here for more of your CCNP Encore show.
Thank you for watching IT Pro TV.